Hello, my name is Kasper Hornbæk. On behalf of myself and my colleague Morten Hertzum, I would like to present a paper that was published in 2023 in ACM Transactions on Computer-Human Interaction. So the main takeaway from this paper is that frustration is still a common experience among users of computers. So what is frustration? We've all experienced episodes where we just cannot use computers the way we want, or when something that we usually do is not working anymore. Such episodes are frustrating because computers were supposed to help us attain our goals, not be in the way. Such frustration has been more formally conceptualized by Katie Bézier and colleagues. Their model, shown on the slides, states that unexpected goal interruption as part of a task is central for frustration. The association between such goal interruptions and frustration is mediated by a number of factors. Some are situational, like the importance of the task. More important tasks make you more frustrated. And others are dispositional factors like self-efficacy. Finally, the model separates at the bottom immediate frustration from the escalation of that frustration to a broader range of emotional outcomes. Frustrations have also been related to usability. Brian Shackle, for instance, in the mid-80s, defined usability in a way that identified frustration as one type of negative attitude towards computers. So frustration seems to be quite central to HCI. So what do we actually know about frustrations? To answer that question, we need to look at a strand of 5 papers published between 2003 and 2006 by Bézier, Lazar, Snyderman and others. The most impactful of them are perhaps the paper first authored by Serpao in 2004, and I'll focus on that next. Serpao used modified time diaries to study 111 participants' frustrations as they occurred during their computer use. The most troubling finding from this study is the quantification of the amount of time lost to frustrations. Serpao and colleagues found that about 50% of the time spent using computers are lost to frustrating episodes. To me, this is just such an astounding number. Half of the time is simply lost when computers were used. With the present study, we wanted to investigate if this and other findings from Serpao still hold. There's a couple of reasons to do so. First, we're only aware of one replication of the above results. That replication had fewer participants but found only half the rate of frustrations among users. Second, much has changed since 2004 regarding technology and its use. Perhaps computer technologies have matured. Perhaps user-centered design have made computers easier to use. One could hope so, but it remains an open question. And third, the method used in the original study include the requirement that participants had to report at least 3 frustrations. And critics might argue that this inflates the frequency of frustrations. In addition, the participants in one of the original studies were computer science students who may be much more alert to computer shortcomings, but also much better equipped to resolve them. So we recruited 234 participants through Prolific to keep a 1-hour log of frustrations. Our methodology is quite similar to the study by Serpao and colleagues, with a couple of exceptions. Because it's crowdsourcing, if the participants had not reported anything for 10 minutes, we reminded them with a notification to either log something or dismiss the notification. Participants were free to choose when they would complete the 1 hour logging. We asked them to participate when they would be using their computer as they would on any normal day. This was to avoid that the frustrations would mainly or only be about crowd work. We also didn't require participants to log a particular number of frustrations, and still we did a number of very careful checks of data quality, which removed 42 participants, bringing the number to the 234 that I mentioned before. I'll just give you a few highlights of the results. You can find many more details and other results in the paper. So the time lost to frustrating incidents varied between 1 second to 1 hour. This time includes the time spent trying to solve the problem and the time spent recovering from any lost work. Across the 1 hour reporting period, the participants lost an average of 6 to 12 minutes due to frustration, corresponding to 11 to 20% of the reporting period. Some participants reported losing more than an hour. This was either wrong or they included time lost beyond the reporting period. So this is why on this slide we give an upper and a lower bound for the time lost, where we have adjusted the times higher than an hour down. The time lost to frustration has dropped from about 50% in the study for SERPAO. While this drop is gratifying, the time lost is still high. Imagine the consequences if our results generalize. For each 5-day week of computer work, between half a day and a full day will be spent in frustrating episodes trying to recover from losing work. The frustrating incidents happened during tasks with a median importance of 7 on a 1 to 9 rating scale. This also caused quite high frustrations, so participants' self-rated frustration was also 7 on a 1 to 9 scale, where 9 is the highest. And as expected with increased task importance, of course, participants report a higher level of frustration. These numbers are very similar to those of SERPAO et al. About 3 in 4 incidents are resolved. So this might happen by putting in extra effort or waiting for the issue to resolve itself. Some participants repeated previous steps, they took another approach, or they settled for a lower quality result. In about 26% of the incidents, participants were unable to resolve what caused them frustration. And then they had to decide to not care. One said, it's not important enough to me to care to resolve it, I just give up. They might have to postpone further work on the problem until a later time, or switch to a completely different activity to shake off the frustration. Participants report that frustrations have often happened before, and they also report that they expect the frustrations to happen again. The number for the latter is 87%. So in this way, frustration is integral to how people experience computers. They are not solely experienced as empowering, fun, or supportive of creative expression. They are also a source of repeated frustration. It's important to note that this is not the consequence of limited computer experience. On the contrary, participants tended to be experienced with computers and then used them for a medium of 6 to 8 hours a day. They also reported high self-efficacy with computers. In the individual description of frustration, there's a lot of interesting stories and a lot of interesting insights about how systems cause frustration. We classified those in 3 groups. The individual stories, I will have to refer you to the paper to read. So poor performance is the most common cause of frustration. About half of the incidents concern slow application, freezing systems that crash, which is very similar to earlier studies. Second, there's a group of about 16% of frustrating incidents, which can be said to be due to poor utility. In these incidents, frustration results from a mismatch between what the system can do and what the user need. So absent functionality, unsatisfactory content are typical examples. And third, poor usability is the cause of 1 in 3 incidents. And these incidents concerns disruptions in the flow of activities, operations that are just hard, difficulty finding things or information, pop-ups, making the wrong selection, or having forgotten how to do something. So these were the main results. A central question for us that actually has really puzzled us is what to do about these results. We know how to solve many of the frustrations that we have reported. Categories such as poor information presentation and absent or desired functionality appears to be solvable through increased use of user-centered design. It just don't seem to happen. There's a large catalog of frustrations that suggest many things to try. The types of frustrations that participants report offers many ideas for SIGCHI and computer science. For instance, it seems that operating systems could be developed to protect users much better from frustrations, in particular relating to crashes and unresponsiveness. It's also a fact that hardware decays, but hardware that decays need not degrade the user experience. A gracious adaptation to decay should be possible, either manually, as when one can select the display resolution that measures the strength of one's graphic card, or automatically. Poor performance in the form of slow, freezing and crashing systems are prominent examples of poor usability. We could be much better with dealing also with this gracefully in the user interface. And we also think in particular that careful engineering of the user's experience of time may reduce the perceived waiting time and therefore the experienced frustration. Now this is a very particular method modeled on the studies by Pao and colleagues. But we think other methods such as experience sampling methods should be used to corroborate the results. Some users don't report any frustrations, and we think that experience sampling might be interesting to use for that group so that we are sure that they don't experience frustrations and not just skip reporting them. So in conclusion, frustration is a common user experience. We see that between 11 and 20% of the time people use with computers are lost. Collectively, these issues delay or obstruct users in doing what they want their computer to help them with, and thereby they make frustration an integral part of how users experience computers. Removing or just even reducing the sources of frustration poses quite big challenges for computer science in general and specifically for our field, human-computer interaction. Thank you for your attention.